I'm John, and this is my partner Adam.
Hey.
We are presenting our automated plant grower project. The original concept was to create an enclosed environment which was automated to grow plants. To decide how we wanted to build it, we first needed to decide what plants needed, which were the basics: water, light, soil, and food. To create a project, we then got the components to monitor these things, like water sensors, pumps, lights, and a microcontroller to control it all.
Alright, well, as you said, I'm Adam. I'm going to discuss the parts that we use to develop our automated plant grower. So the parts that we use, so we got a water tank, which is a trash can, fish tank, buttons, our Arduino Uno, an OLED screen, a couple of MOSFETs resistors, a power supply, LEDs, and a water pump and a liquid sensor, and also a couple of moisture sensors down in the bottom. When we were coming up with our conceptual idea for an automated plant grower, we realized that we needed a lot of power. So this power supply provides 5 volts, which is what most of our components need, but also provides 12 amps to make sure that we get enough power for our LEDs, pump, our Arduino, and our screen. And also our level and moisture sensors. Now, to show this in operation, we have our start screen up already. On our start screen, we have the name and mode selections for our day and night cycles for our plants. For this, we've programmed 3. We have an 8-hour day cycle and a 16-hour night cycle, and then a 12 and 12, and then a 16 and 8. These simulate basically the shade, partial shade, and full sun cycles that most plants need. Once a user selects whichever one they want, they push the start button. The start button automatically puts you in the day cycle and starts measuring the moisture in the soil. Unfortunately, one of our sensors is broken, but we still have one that works. So we have our LEDs right here, our water tubing, and also 2 moisture sensors down there. To show the watering cycle, we'll push this button right here. This turns off the LEDs and turns on the pump for about 3 seconds, and then waits a second before turning on the LEDs. In this case, this ensures that we get a more accurate reading of our moisture as the water settles into the soil. And now, there's a lot of different things that can be done with this project that can be improved upon, but because of budget reasons, we weren't able to do so. One thing that could be done is that it could be Wi-Fi enabled or wireless, so that way people can check on their plants even when they're not even at home. Another thing is to make it even more of a controlled environment, is that you can include heating elements, moisture, humidity sensor, and temperature sensor, fans to make sure to basically make you able to program almost any artificial environment that you need. And this can also be implemented bigger or smaller depending on your plant's needs.
We decided to use the Arduino Uno. This meant that we were required to use a round-robin operating system. The round-robin operating system requires large amounts of power because it is constantly cycling through the code. If we wanted to implement a more low-power design, we would need to use a different microcontroller that would run a real-time operating system. So when we were building this project, we wanted to make it different than most commercial growers that you can see online. What made us different is our automation of watering. Usually with those commercial growers, it has a reservoir of water and something that'll chirp at you when the soil is dry, but doesn't have a system of which to water them. They also don't usually have displays or cycles that are different. We have a display, and we have 3 different cycles you can choose from. To use this in different applications like farming or even greenhouses, you would want to make it a bigger application, a smaller application, or even remove direct power and use batteries. Something else you would want to use is more durable parts like the moisture sensor, or just have a different design mechanically. And that is our project. We went with the Arduino Uno as our microcontroller. This meant that we were going to use a round-robin operating system. This operating, why did I